So, we are starting our discussion on module 2, that is atomic and molecular structure. For those of you who are familiar with the atomic and molecular structure, it may be a repetition. For many of you it may be, for others it may be just a reminder of the things to come. I need not explain to you more about it, but we will go about our business of introducing you to the subject. Okay. Now, a little bit of ancient history and India. Atom in Hindu scriptures. This I have prepared specially for you. For many of us think that we don't know much about in science in India, but the facts prove otherwise. Ancient Hindu scriptures recognize that matter is made up of very discrete particles known as Kana, Anu and Paramono, which are the rough equivalent of a molecule, atom and subelectronic particles such as electrons, positrons, etc. That means, the awareness of the atomic particles and subatomic particles was there in India much before the actual advent of science through the Renaissance, somewhere around 15th, 16th century in Europe. Okay. Now, what is a Kana? It is a little bit of Sanskrit word. Kana, many of you may be familiar, and for those who are not familiar, Kana is the aggregate of smaller particles called as Anu, atoms, but it is not visible to the naked eye. Kana, Anu is not visible to the naked eye, but Kana is visible to the naked eye. You can roughly describe it as the smallest particle that is visible and existing independently. Okay. So, that is a grain of jawar probably, or wheat is the smallest particle you can see, that is called as Kana. Similarly, a pinch of salt, the first nucleus of the salt when you are crystallizing, probably that is also called as Kana, and an aggregate of Kana is a normal material what we are very familiar. But as far as our understanding is concerned, the Kana is the smallest particle that is capable of independent existence. Okay. So, you look at it, you will recognize that yes, this is this material, this is jawar, this is wheat, this is rice, this is sodium chloride. Like that, the smallest particle that you can see from the visible eye should be Kana, and that Kana is made up of Anu, which is not visible to the eye. So, each substances, Anus of each substances are distinctive and capable of independent existence. Kana is capable of independent existence, but Anus of each substances are also distinctive, but capable of independent existence, but they are not visible. Okay. They are too small for our naked eye to be seen. So, what is Paramanu? Paramanu is the smallest discrete particle capable of independent existence, but it is the part which is common to all. It is not visible to the naked eye, that is Paramanus are essential components of all things we see around us. You can say that like protons, electrons, they are part and parcel of every element as we understand them today. So, Paramanus like protons, neutrons and electrons, positrons, mesons, and so many of them are around, and they are capable of capable of independent existence, but still not visible to the eye, but they are part of every material we see around us, that is Paramono. So, ancient Indian history is in consonance with the concept of the atom, structure of the atom. So, the Hindu mythology routinely describes warheads utilized in the warfare, Ramayana and Mahabharata. You will come across where the wars were fought with several types of warheads described as Brahmastra, Shaktiastra, Nagastra, and so many other possibilities. And these warheads sort of represent the amount of energy that is energy release that is associated with their presence or with their application. For example, Brahmastra is supposed to release so much heat that it burns the whole world, which is nothing but probably our atomic bombs and neutron bombs, hydrogen bombs and so many other bombs. We already have them, but India had them earlier, and unfortunately that knowledge is lost as far as the current modern world is there, but we do have the literature to support these sort of claims. Okay. Now, we come to the modern definition of the atom, and this modern definition of the atom is based on Dalton's theory, that is around 1800. So, 1802 to be very specific. So, the modern theory of atomic structure is based on the Dalton's theory. According to Dalton, what he said, all the matter is composed of tiny real particles, they are called as atoms. He called them atoms, okay. So, which are indivisible and cannot be created and cannot be destroyed. That is one of the theories. Nowadays, we know that they can be created, they can be destroyed, because in the nuclear energy things we do create and destroy the atoms, etc. But at that time probably it was appropriate, and atoms of all substances are identical in nature, weight and other properties. That is another postulate he made. And then atoms of one pure substance and those of others differ in the weight and other characteristics. Okay. So, atoms, he also said, atoms combine in definite proportions resulting in chemical compounds. That means, if you want to make sodium chloride, you have to take one atom of sodium, one atom of chloride, and then combine them to give you one molecule of sodium chloride. Or you can take one atom of hydrogen and one atom of another atom of hydrogen to give you one molecule of hydrogen gas. Similarly, I can take one atom of hydrogen and one atom of chlorine to get hydrogen chloride molecule. Like that, there are different combinations to be mixed in definite proportions. That is what Dalton said, which is true. Now, he made the correct things as we understand them today. Okay. Now, this is what Dalton's atomic model is looks like. Now, here you can see there is hydrogen, there is helium, and then there is lithium. We have one hydrogen nucleus at the center. Around that there is one electron. Helium has got 2 electrons and lithium has got 3 electrons. Okay. Simplest model probably, and subsequent developments in science have led to the expansion and atomic theory, expansion of the atomic theory that is supported by experimental data. A lot of scientists were involved, such as Michael Faraday, Rutherford and many other peers whom we respect, who would have won Nobel Prize every year by now if they were present now, and they developed the theory of atomic structure and the discovery of electron, X-rays, radioactivity, nuclear reactions and subatomic particles. All these things have led to the current understanding of our atomic structure. I am not going to teach you all the atomic structure theories, but Dalton's was the first one. Maybe we will spend some time about Sommerfeld's theory also. So, it is now widely recognized that atoms are composed of several types of subatomic particles. Okay. Some are capable of independence, some are capable of incapable of independent existence, but some outside the atom they could be there and others may be having existence only inside the atoms. So, the others are having extremely short lifespan. By short lifespan, we mean to say it is less than 1 second. No, we mean to say it is less than 10 raised to minus 5, minus 6, minus 16 seconds. They are the short lifespan we are talking about. Okay. So, among the stable particles, only electrons, protons and neutrons have independent existence. So, all these things we see in our day to day life are there are scientific laboratories, physical laboratories where you can infer the existence of electrons, protons and neutrons independently. Okay. So, but they are also present as in the combined form in atoms etc., which I have already shown that hydrogen, helium and lithium figures. Okay. Now, we come to the more 100 years down the line, that is Rutherford's atomic model. So, in Rutherford's atomic model, you can see that I am not going to explain to you all the theory etc., but you can take a look at what he might have said. Now, for those of you who are interested, I can refer to you a couple of books on atomic structures. If you write to me or if you let me know you need to understand, I will suggest you the books and literature which will help you understand the atomic structure as we understand today. But Rutherford was the next very decent development. What he said is that the atom is composed of nucleus and electrons going round and round about it. Okay. Now, you can see that in Rutherford's model the electrons are going round and round. I have not shown the animated picture, but you can see that they are all haphazard. Okay. That means the total atom as a structure is fairly stable. Now, the next model, that is Bohr's atomic model, improved upon that. Then what he said is there are positive protons at the center and then negative electrons around it, but they are all going round and round in fixed paths. Otherwise, a big heavy positive charged particle should keep on attracting the small electron negative element, that is electrons, into it subsequently. So, they must be moving with enough force so that the centrifugal force is enough to keep them in circulation. Okay. So, the atomic particles, cathode rays impart negative charges to objects in their paths and get reflected in the applied electrostatic and magnetic field. So, this is how we infer the existence of protons, neutrons, X-rays etc. So, further it was shown that the cathode rays cause ionization in gases. and when exposed to photographic plates, these yield X-rays against suitable targets. These particles were named as electrons in 1897. That is, when I showed you the Rutherford's model, the electrons were already known. That is why I had shown you the straight away the Rutherford's model before coming to the discovery of the atomic particles. But these particles were named as electrons. They were discovered by Sir J. Thomson, very leading experimentalist and most celebrated atomic scientist. And Thomson evaluated the ratio of the charge to the mass ratio. This is his real contribution. So, what he said is the electron from different sources he obtained in the cathode rays, and he showed that all of them are identical. That means, if all of them are identical, it means they are all the same particle, but they come from different elements. So, these particles are the common components of all elements. That is the conclusion. So, what did he do? He said, okay, let me measure the mass of these particles, let me measure the charge of these particles, and then see how they compare. So, he showed them to be identical, having a charge of minus 4.8029 into 10 raised to minus 10 and an atomic mass of 0.000548 atomic mass units, or if we want to convert them into the grams, it is 1.6603 into 10 raised to minus 24 grams. These kind of numbers were generated in 1897. For common man, it is difficult to imagine these numbers even now, isn't it? 2018, it is difficult to remember these numbers now, but these numbers were generated in 1897. We should remember that. Okay. So, another particle that was discovered was proton, and look at this slide now. The protons were also found to be identical with hydrogen atoms. Okay. So, the hydrogen atoms, once you remove the single electron, what remains is a proton, because the hydrogen has got one proton and one electron, nothing else. So, you remove the electron, what remains is proton. You can call it H plus or hydrogen proton or simply proton, whatever it is. So, just like electrons, protons are also found to be present in all types of atomic species and hence considered as a fundamental particle whose mass is 1.00757 atomic mass units and carry a charge of 4.8029 positive charge. That means, if you take protons and neutrons, the proton is quite heavy, because in atomic mass unit, look at this 1.00757 AMU, and what is that of electron? 0.000486, correct. So, electron is very small, having very small weight compared to 1.00757 atomic mass units. So, obviously, if you take a ratio, it works out to approximately about 1640. That means, an proton is 1640 times more heavier than the electron. Okay. Then there were other particles that were found out, and one is neutron. So, neutron, the bombardment of light elements such as iodine, beryllium, boron, etc., with alpha particles, they yield penetrating radiation consisting of neutron particles. Approximate mass unit is according to the reaction. Here I have written the nuclear reaction, 4 charge, 9 mass. Whatever I am writing at the top is the mass, whatever I am writing at the bottom is the charge. So, beryllium plus helium goes to 12 C6, that is carbon atom of 12 atomic mass and 6 atomic charge, okay, plus it releases 1 neutron of 0 charge and 1 atomic mass. So, the proton and neutron are differing from each other only by the number of charges that are present. Neutron has no charge and proton has got 1 charge, 1 atomic mass unit, 1 charge. So, by convention what we say is the charge of proton is 1, the charge of electron is -1, charge of neutron is 0. So, we continue our discussion. So, cathode rays, this I have already shown now, next one I should show you, yes. So, that neutrons produced by the reaction of beryllium with helium to give you carbon and neutron are known as neutrons. They have a mass of 1.00757 AMU. So, neutrons are unstable outside the nuclei, that we should remember. Okay. Outside the nuclei on their own, neutrons are not there, they are all heavy energy particles and they keep on running around until they hit something and then get absorbed. So, over the years existence of number of other unstable particles have been proved. These include positrons, neutrinos, antineutrinos, mesons, etc. These are all unstable particles. Okay. So, however, such particles are generated only under extreme laboratory conditions, and the composite particles of hydrogen known as deuteron and doubly charged helium nucleus known as alpha He2 plus are known to exist. Then somewhere around 1925, de Broglie advanced the theory that the electrons also possess wave properties such as reflection and diffraction. So, you see basically electrons, if they are very small particles, you throw them, they move like a ball, but if it is very small particle, it moves like this. You know, it may not go like a ball and straight forward, but it may show some vibration. And this kind of observation on small electrons, if they are going in some fashion which is not a straight line, but as a wave, then they should also exhibit the properties of the wave, is it not? What are the properties of the wave? It must have an amplification, it must have a number of cycles, the number of cycles should be uniform, and all those things are involved. Nowadays, we know that all electrons and many other things are like part of our electromagnetic radiation, which have got amplification, which have got number of cycles, etc., hertz and all those things we know. But in 1925, that was the time when these things were postulated. Okay. Now, this formed the de Broglie's discovery formed the theoretical basis of extranuclear structures of the atoms. That is very important. So, extranuclear structure of the atoms are we understand even the nucleus is composed of different things. It is not just the electrons outside the atom, outside the neutrons and neutrons at the center. Now, we also know that the nucleus of an atom itself is different, that can contain a lot of things. We will study them a little bit. Now, Rontgen's experiments on the bombardment of a target with cathode rays yielded a highly penetrating radiation of short wavelengths, which he called X-rays. So, the discovery of X-rays was also a very important milestone in the development of science, and such radiation is due to the energy released when an inner electron, going around the nucleus, it is released, and other electrons, when one electron is knocked off, the electron from the another orbit falls into that hole. So, that radiation corresponding to that energy change is known as X-rays. Okay. So, when the inner electron is released, other electrons drop into the vacant plots and X-rays are generated. So, therefore, an atom is believed to consist of two parts, namely, that is a positively charged nucleus which is small in size. So, what is the size of the nucleus? It is about 10 raised to minus 12 grams centimeter size. Now, we are talking about the size, and we can talk about the radius or diameter. So, it is about 10 raised to minus 12 centimeter and comparatively heavy, because we have seen that both neutrons and protons are quite heavy particles in terms of atomic mass units, which I have shown you in the slide earlier. So, an extranuclear arrangement, another part of the nucleus of the atom is the extranuclear arrangement of the electrons going round and round, loosely arranged, and they are not rigid particles fixed in a particular place, no, but the electrons keep on moving around the nucleus, just like our planets keep on moving around the sun. That is the best analogy so far anybody has provided regarding the structure of the atom. So, all our planets keep on moving around the sun. We are also stable on the earth. Moon is stable, earth is stable, and then the Mercury, Venus, Mars, and so many other bodies which are satellites of the sun, planets, etc. They are all stable. That is the analogy we normally accept, and these are loosely arranged, electrons are loosely arranged around the nucleus in a space of about 10 raised to minus 8 centimeter and diffuse in character. Now, just imagine nucleus is 10 raised to minus 12 centimeter, and the size of the area of the size where electrons are around the nucleus is 10 raised to minus 8 centimeter. That means, the total area occupied by the electrons around the nucleus is 10,000 times larger than the actual size of the nucleus. Nucleus is 10 raised to minus 12, and 10 raised to minus 11 is 10 times more, 10 raised to minus 10 is 100 times, 10 raised to minus 9 is 1000 times, and 10 raised to minus 8 is 10,000 times larger area around the nucleus. That is where all the electrons are hanging around, but they are all bound to the electrons, okay? But they are all bound to the same nucleus and they cannot escape. Electrons cannot escape from the nucleus, nor will they fall into the nucleus, because they are all going round and round, and that is Bohr's theory. Okay. So, the nucleus, the further understanding of the nucleus and chemical properties come from our studies on the nucleus. Nucleus governs the physical properties of the element, and the extranuclear structure is considered as responsible for the chemical properties of the element. Okay. So, the alpha particle is used as a bombarding particle, and neutron is a product of radioactive decay, that we know. Unstable particles and composite particles do not have any role in the ultimate composition of the matter. So, that means unstable particles and composite particles, they are part of the atoms, but they have no role in shaping the properties of the metals or elements, and they are there. They will be produced under special circumstances, but they are all part of the system, sort of dormant, we can say. Okay. So, that is our understanding of the nucleus, and our time next class we will know a little bit more about the Bohr-Rutherford theory, etc., and that is the modern atomic theory. Okay. So, thank you very much. I hope this much of information has been useful to you.